Okay, so we did the stick exercise, right? And when we did the stick exercise and you found out that the two smaller sides added together always has to be greater than the largest side, that theorem has a name. And that name is called the triangle inequality theorem. That's the theorem that you actually were experimenting with. I have another experiment with the mid-segment of a triangle theorem, but we're running out of time because we're behind a little bit. So I'm going to skip that experiment. Okay, we're also going to use what's called the hinge theorem to identify the length and order of side lengths of a triangle and angle measures. It's called the hinge theorem because of a hinge on a door, and I'll demonstrate that in a minute. And then you're going to be solving for missing sides of a length for triangles. Turns out in geometry, we spend a lot of time. We're going to be spending like 3 weeks on triangles. Okay, so vocabulary. This should have been the first part, right? Triangle equality theorem states that the sum of any two sides of a triangle must be greater than the measure of the third side. The faster way to do that is just to do the two smaller sides and compare it to the third side, the larger side. Theorem is something that can be proven. You kind of proved it. That's called an induction proof when you are like experimenting many times to try to figure it out. It's not a deductive proof. Okay, can I move on? Okay, so let's look at these three examples. What are the two smallest sides right here? I have 10 and 11, right? So what you're going to do is you take the two smaller sides, you're going to add them together and see if it's bigger than the third side. If it's bigger, then you say, yes, it will make a triangle. If it is not bigger or greater, then you'd say, no, it does not make a triangle. So is 21 greater than 12? Yes. So will this make a triangle? Yes, it makes a triangle. Now, what are my two smaller sides, for example, 2? 10 and 8. So 10 plus 8, is that greater than 18? Is 18 greater than 18? No, it's equal. So it will not make a triangle because you'll have a little gap when you're trying to pop up those sides, right? What's my two smaller sides right here? 6 and 9. I'm going to add 6 and 9 together and see if it's greater than 11. 6 plus 9 is 15. Is that greater than 11? Yes, so this does make a triangle. Now, sometimes, let's say you're a farmer and you have two lengths of a fence and you're thinking about doing an enclosure, and so you want to say, oh, well, I want to save money, so I only want to buy another length, and I'm trying to figure out what length that fencing could be so I can make a triangle so there's no gaps, right? And this is how you do it. Since the third side cannot be larger than the other two added together, you can find a maximum by adding the two sides together. Since the third side and the small side cannot be larger than the other side, we find the minimum by subtracting the two sides. And I'm going to show you how to do that. So, example 1. To get the minimum, you subtract. What is 14 minus 6? Not 8? Right? Okay, what is 14 plus 6? 20. So the length of like that third side would have to be greater than 8, but less than 20. And make sure you know how to write it like this. I've seen some weird ways people write it. You put an X in the middle, right? And then 2 lesson signs. You put the smaller number here and the larger number there. So, what would I do for this next one? What do you think? 11 minus 8 is what? What's 11 minus 8? 8, 9, 10, 11 is 3. And then what do I do over here? 11 plus 8, which is 19. Why don't you do example 3? And at your tables, check each other's work and make sure you're getting the right answer. So what did we get? 1 and 19. It has to be greater than 1, and it has to be less than 19 because you take 10 minus 9 and 10 plus 9. Okay, who's got this? Little thumbs up if you got it. We got it? Give me a thumbs down if you're like, I'm totally confused. Which you can, because sometimes I can be confusing. Are we good? Good. Okay. Now, I'm going to come over here and I'm going to show why this is called the hinge theorem. And for those who are trying to watch this, I'm sorry, I can't get a door on. Excuse me? Yes. Because I'm going to go back and watch it. Okay. This is pretty far open angle, right? Do you see an angle? Okay. I want you to look at the side opposite, which would be this corner to this corner, right? Pretty long side. Now, there's hinges on the door, so I can open and close it. This is why it's called the hinge formula. The hinges are right here. So if I close this a little bit, what happens to that angle? It's smaller. What happens to this side? It's smaller also. Do you see the relationship? As this angle gets larger, the corner to corner gets bigger. As it gets smaller, right? Corner to corner gets smaller. And that's called your hinge theorem, okay? Hello. Third period? Oh, okay. My fourth period? I teach financial foundations. Teach all about money, taxes, and all that fun stuff. Just that's that board right there. Okay. So, if I know this relationship, I'm going to look at this triangle, right? Here's the smallest angle. Do you all agree that angle C is the smallest angle? Everybody agree? Okay, the opposite side will be your smallest side, right? So I'd write A, B. What's the next largest angle? 59, right? So, and that's angle what? A. Okay, the next largest side would be opposite. So that would be what? B what? BC. You need two, I've gotten this on test too. You need two letters to give me a side length. If you only give me one, I have to mark it wrong. Because B is not a side length, right? BC is a side length. AB is a side length. What's the third side length? AC. Now, if you told me CA, would I mark that wrong? No, because AC and CA mean the exact same thing. What's the largest angle? Angle B. You got it? Saw some people squinting. Is that better? I don't like squinting. Like you be able to see. Okay, so over here, order the side lengths from least. What does least mean? Anybody know what least means? Small, little. Least means smallest, little. What's greatest? Big. Right? Okay, now we're going to use the hinge theorem. Which one of these is the smallest angle? Angle 38. It says here we want to order the side lengths. I'm waiting until it's quiet. Okay, here's the smallest angle. The opposite side would be the smallest side, right? So what side is that? XW. Smallest angle is always across from the smallest side, opposite. Okay, what's the next angle measure? The next largest? 68, which is angle X. Good job. And then across will be the WY. And then angle W, right, is the largest, and it has to be across from the largest side, which is XY. Okay, you do this one at your tables. I'll walk around and check your work. So for this one, the smallest angle was here. So you had XV. The next one was WX. And then the last one was WV. Questions? Concerns? Okay, now they gave you the sides, and you have to figure out the angles. But this one, what? Look at that. They're the same, which leads us to another theorem. In isosceles triangle, the angles opposite the congruent sides are congruent. So this angle and this angle have to have the exact same measure. Okay? Now, number 10 is your smallest side. So the smallest angle is going to be angle T. But here, angle U is going to be equal to angle V because the opposite sides are equal or the same. Anytime you have a triangle with two sides equal, their two opposite angles will also be equal. Interesting? Not interesting? Somewhat interesting? No. Okay, what about this one? This one's a little easier because they didn't have any congruent sides. Somebody raise me their hand and tell me what the smallest angle is going to be. Raise your hand, raise your hand, raise your hand. Okay, go ahead, Patricia. Angle T, because here's the smallest side. Opposite angle, angle T. Right? Leon, is that how I say your name? Leon? Okay, Leon, which one's going to be the next largest? You're not Leon, but she is correct. So, Leon, see how 17 is the next largest? Opposite angle is R. And then what would be the last one? S. Because, oh, why is it doing that to me? Interesting. Angle S. We must have had some type of glitch in the internet. 140 isn't coming up yet. There it goes. Okay, now you're welcome. Okay, this next one is called the mid segment of a triangle. A mid segment is a segment that connects the midpoints of two sides of a triangle. This segment is always parallel to the third side. Parallel lines have the same what? Parallel lines have the same slope. Everybody say that. Parallel lines have the same slope. Okay. The length of the midsegment is half of the length of the third side. So, see here how angle, this is 8 and this is 16. This is a mid segment because it said so right there. So that would mean that D is the midpoint of AC. E is the midpoint of CB, right? These two lines are going to be parallel because they are parallel, their corresponding angles will be the same. So this angle and this angle will be the same. And this angle and this angle will be the same. We're going to talk about that more tomorrow when we get to similar triangles. And everybody's going to say, ooh, yay. Okay. So, right here. If UV is 7, and I'm showing that this is the midpoint because MU is equal to UL. I'm trying to get the whole thing up there. And then V is the midpoint of LK because these two pieces are equal. What's the length of MK? Let's say over here. If this is 8, this is 16. I double the midsegment to get the opposite side. So what's this one? 14. It is 7 times 2 is equal to 14. So what would this one be? 16. 8 times 2 is equal to 16. Uh-oh. Uh-oh. Any ideas? What am I going to do to figure this out? How am I going to set this up? Go ahead. Yes. If I double this or add it to itself, which means the same thing, it will equal this over here, right? You can use my electric pencil sharpener. Go ahead. I'll stop. Thank you for being considerate. I appreciate it. Just like when we did midpoints on our tests, there's sometimes I have to double things and set it equal to the opposite. So I had to double this mid segment and set it equal to the opposite side. 2 times 2x is 4x plus 68 is equal to x plus 32. I'm going to subtract x on each side. I get 3x plus 68 is equal to 32. I'm going to subtract 68. 3x is going to equal a negative, what, 36? So x is a negative 12. Now, x can be negative, but the length shouldn't be negative. Did it ask for the, it just said solve for x, but Miss Dawn always likes to check her work because she's always been that way, right? What's 2 times a negative 12 plus 34? What's 2 times a negative 12? Negative 24 plus 34 is equal to 10. So JI is 10. Now, when I put a negative 12 here, what's a negative 12 plus 32? 20. And good, this is half of this, so I know I did it correctly, right? Did I have to do that? No, it didn't say so in the directions. But if I have extra time on a test, I may want to check my work, right? We good? Can I move on? Because I only got you for 5 more minutes. Okay. So what would I do? Everybody do this one now and see if you can find the right answer. And I did it up here if you want to check your work real quick, just because we're running close on time. Yeah. So I got one more to do. So you should have, did everybody get x equals 7? Okay, one more, and then you guys could go on your merry way. 2 times x plus 21 has to equal x plus 32. 2x plus 42 has to equal x plus 32. So I would get minus x, x plus 42 is equal to 32. Subtract 42. X would equal negative 10, which this then would be 22, and this would be 11 if I threw it in. So, yep, makes sense. Okay, so keep your notes. I'm going to give you some new notes tomorrow because it's pretty easy. And then we will spend time practicing these notes and the new notes. And then hopefully we'll get to similarity tomorrow. Okay? And then I think I'm on schedule from where I needed to be.